So here I have a square, and I can tell you that each side length of this square is 1 inch, which means the area inside the square, I would call that 1 inch squared, right? So I can measure from here to here as 1 inch, same for each side here, but then the area inside we would call 1 inch squared. This is a square inch right here. Now, here I have a cube, and the cube, right, each face here we got blue and green is 1 square inch. But the volume of this cube, I'm going to say, is 1 inch cubed. And I write this exponent of a 3 here. So each side length here, each edge of the cube is 1 inch. The area of the face is 1 inch squared, but then the volume of this is a cubic inch here. It takes up a cubed inch of space. All right. So I have here, let me adjust my camera, this cube here. And I'm wondering how tall this cube is. I'll put 1 cubic inch kind of right next to it. You can kind of think, how tall do we think that is? Now, what I can tell you is that the volume of this cube here is 64 inches cubed, which means that I can fit 64 of these inside of here. All right, I want to know how tall it is. Now, you might be like, oh, Mr. Drago, I know that the square root of 64, because that's something we've learned about, is 8. You might think that is 8 inches tall. But that would be wrong. That would be, remember, if we're dealing with square roots, right, this would be as if we had a square that was, here, I'll draw that a little bit lower. That would be as if we had, like, if this was inside a square, that would be if the square was 64 inches squared, and that would give you the side length of a square. Here we're dealing with a cubed. So, we can't use square root to find the height of this cube, right? Given the volume of the cube, how do I find the height? We're going to use something called a cubed root. Kind of like a square root, right? Except there's a 3 here telling us, no, this is a cubed root. We're going to find the cubed root of 64, right? Now, how does that work? So like a square root, where you find the number times itself to give you that number, I'm wondering what number times itself 3 times equals 64, right? Here, let me write that a little bit lower here. So a number times itself 3 times. 1, 2, 3. Different from a perfect square, where it just times itself by once here, right? So I want you to think about that, right? 2 times 2 is 4, times 2 again will give you 8. It's not that. 3 times 3 is 9, times 3 again is 27. It's not that. Let's try 4. 4 times 4 is 16, times another 4 is 64, right? So that means that the cubed root of 64 is 4, because 4 cubed would give me 64. And so what that means is for this volume here, the base, the height, the width here are all 4 inches long, right? And 4 times 4 times 4 would give me the 64. Let's check. All right? Oh, the top here isn't filled in, but we can see that if I had enough blocks, right, it would be 4 high, 4 across, 4 deep there. There would be 64 blocks.